Hello and welcome to our project about spam email detection using neural networks in MATLAB.
So for our project, we will examine the performance of neural networks and models to predict whether an email is spam or not. We will be using pattern recognition and classification using mathematical models formulated in MATLAB. The point of this algorithm is to declutter people's email feeds. We have taken our dataset from UC Irvine. It consists of 4,601 emails, and there are 57 attributes that they have determined are important when determining if an email is spam or not. Each attribute is a value, and these values are a percentage in the email that match the word, meaning of the number of times the word appears in the email divided by the total of words in the email multiplied by 100. Some of those words that they deemed important were money and receive.
This is our mathematical model for our network. We used the model from the PowerPoint our professor gave us as a reference from class. As you can see, we have our 57 inputs representing our 57 attributes. These 5 equations with the A at the beginning are saying that the activations of each of the units in the hidden layer are functions of the weights controlling the function mapping from one layer to the next. These appear in the hidden layer. G is the sigmoid function in these equations. We have 5 of these equations since we have 5 hidden neurons. H of theta is the output value. We created 5 neural networks during the duration of this project. The first contained just our original data set. Then we created a model with the 56th and 57th attributes scaled down. A few spam emails were being categorized incorrectly by this neural network, and we noticed that they all had a common attribute, the 14th. We thought that this attribute might have been affecting our results, so we scaled down the 14th attribute, and it improved our results. It better classified email that was not spam. After that, we tried to improve our network further by comparing their performances if we changed the number of hidden neurons. First, we created one with 10 neurons. The second one we created had 5 neurons, and it performed better.
And now a live demonstration and explanation of our neural network.
We used the neural network pattern recognition app in MATLAB to create our network. To train our neural network, we loaded data copied over into MATLAB from Excel, and we have 4,501 samples of the email data in MATLAB right now. We had taken 100 samples from our previous 4,601 sample data set in order to test our neural network on data it had not seen before. The inputs contain 57 attributes describing the samples, and the targets indicate whether the corresponding samples are spam or not spam by using a 0 or 1 respectively. In this way, the neural network will learn to filter through the data and distinguish between spam and email that is not spam. So I'm going to load in the X inputs, which is our input data with the attributes, and then the Y targets, which is what they should match up to. Then we have the data samples split between training validation and test data. We used the default values. To create our best neural network, we chose to use 5 hidden neurons. Then we trained our neural network. We used the percent error values and the confusion plots, primarily the confusion matrices, to determine whether our neural network was reasonable or not. Then we made our neural network function that derived its values for the weights and biases during training over here. Now we are going to demonstrate our best model. We left out 50 spam samples and 50 samples that were not spam from the original data set to use as test samples for our neural network model. Note that each sample contains 57 attributes describing the data. So when we input the 50 test samples, the model will return a 50 by 1 matrix of ones and zeros. Normally, because the neural network uses the sigmoid function, it would return a percentage for the probability that a sample is spam, but we set it up so it would just return ones and zeros by using the round function down here in line 45, so that it would round our output to either 1 or 0. If it predicts an email as spam, it will return a 1 in the row of the input matrix represented by the 57 attributes. Otherwise, it will return a 0. Now I will input 50 samples of spam data into our best neural network model. Our results indicate that the first neural network correctly categorized 41 out of 50 spam emails correctly. If I scroll through, you can see that there are 9 zeros. Now I will run the data samples that are not spam through the network. This time it returns only 2 ones and 48 zeros. We expect to receive a 0 if an email is not spam, so this model performed quite well, correctly categorizing 48 emails that were not spam.
These are the confusion matrices concerning our neural network. We trained the neural network with 10 neurons on first and saw the results. Although these results are not bad, they are actually really good results. We wanted to see if there was any way that we could improve the neural network. We retrained the network, but this time with only 5 neurons, and we received better results in all categories except for one, the testing category, with only a 0.03% decrease in accuracy, but the overall accuracy of the neural network improved 1.5%. With the 100 data points that we withheld, 50 spam, 50 not spam, we ran them through the neural network separately for our own purposes of testing. The picture on the left shows the accuracy of the neural network with 5 hidden neurons versus 10 hidden neurons with the not spam data points. As you can see, the 5 neuron model accurately determined 3 more emails than the 10 neuron model. The picture on the right shows the accuracy of the neural network with 5 hidden neurons versus 10 hidden neurons with the spam data points. As you can see, the 5 neuron model accurately determined only 1 more email than the 10 neuron model.
Through the study of email classification in neural networks, we saw that our neural network was better at detecting not spam emails than spam emails. We believe that this may be because that the data set may not be looking for the right words that make an email spam. Although they covered a lot of words that make an email spam, they did not cover all of them, which is an impossible feat, we understand. But it has affected our neural network. For example, there are some words that they determined made an email spam, like money or credit, but they did not include words such as congratulations. This may be something that we could look into and see if we could improve the network by getting rid of some attributes or words that we feel are unimportant and adding attributes that we feel are important. We also saw that the neural network reportedly did better when there were only 5 neurons rather than 10 neurons. This is something that we have discussed in class, that the less hidden neurons that the data has to go through, the more accurate the network is.
Thank you for watching.